Okay, so this is a video for lab number 5, which is on superposition theorem. Superposition theorem states that in a linear circuit with several sources, the current and voltage for any element in the circuit is the sum of the currents and voltages produced by each source acting independently. So in multisim, we've constructed the 3 circuits, one with both sources, one with the 5-volt source and one with the 15-volt. We've placed the multimeters and ammeters in the circuit to measure each, and we can see here that on the top one, with both sources on, we get a reading of negative 238 millivolts and negative 1.08 milliamps. And then for just our 5-volt source, we're going to get the current to be 1.19 milliamps and the voltage to be 2.619 volts. And with the 15-volt source, we have a current of negative 1.299 milliamps and a voltage of negative 2.857. If you total these up, you'll get about negative 1.08 milliamps and negative 238.095, which is what the original circuit with both sources on is, so it proves your superposition circuit. Okay, so this is the circuit built for part 2 of the lab number 5. First we have your first resistor, which is 1.2 kilo ohms, your second 3.3 kilo ohms, and R3, which is 2.2 kilo ohms. And then you can see both wires, red wires are your sources, 5 volts and negative 15 volts, and then the green wire is to ground. So first we're going to do the current for both sources across R3. And we see a reading of 0.1 milliamps. So next we'll do the voltage across R3 with both sources. And we see a reading of negative 0.4 volts. All right, next we'll short circuit the 15-volt source. And we'll measure the voltage again across R3. And we get a reading of 2.5 volts for both sources. Now we'll do the current. And we have a reading of, and for the current with the 5-volt source only, we have about 1.2 milliamps. All right, and now we'll use the negative 15-volt source, and we'll short the 5-volt source. And first measure the current across R3, and we have a reading of negative 1.3 milliamps. And next we'll measure the voltage across R3. And we have a reading of negative 2.9 volts. And if you were to add these two together with the 5-volt source and the negative 15-volt source, you would get your total, which we first found to be negative 0.1 milliamps, and your voltage across R3 to be negative 0.4 volts. You might notice some of your values are different than your multi-sim circuit, and that's because the resistors are not actual, they're actual values. We didn't have a 1.2 kilo ohm resistor, 2.2. There was slight deviation between those, so when you put it on the breadboard, your values will not exactly match your multi-sim.